Hi guys, welcome back to another fun day of math. And if it hasn't been fun, well, thank you for pretending like it is. So let's do this. Today, as the heading suggests, we are going to be solving quadratic equations by factoring. So before we can begin to solve our first quadratic equation, whatever that is, let's go ahead and open it up with some definitions. So a linear equation. A linear equation is said to be written in standard form if it looks like this. This pen doesn't have ink. Remind me to toss it in the trash. Yeah, who hides this? Okay, doesn't have ink, but I guess I needed to refill it. Been trying to save money. Okay, so a linear equation is said to be in standard form if it looks like this: ax plus b equals 0. Okay. A quadratic equation is said to be in standard form if it looks like this: ax squared plus bx plus c equals 0. So many moons ago when we had discussed solving linear equations, we just focused on the word equation part, and then I said we're going to table later why we call it linear. Well, it is later now, so let's do this. A linear equation is the special name given to an equation of degree 1. So an equation where the highest power on any of the variable terms is 1. A quadratic equation is the special name given to an equation of degree 2. So an equation where the highest power on any of the variable terms is 2. Okay, so now what's so special about linear equations? What's so special about the degrees of equations? The degree is expected to tell you how many solutions you are expected to have. So for linear equations, the degree is 1. If the degree is 1, I'm expected to have one solution. Okay, notice how I said expected to have, because some of the linear equations that we knocked out back in the day didn't have a solution, or it had many solutions. Okay, a quadratic equation, what is that? No, sorry, the degree. So the degree of a quadratic equation is 2. If the degree is 2, then we're expected to have 2 solutions. Okay, expected is what I'm trying to highlight. Degree 2 or quadratic equation may have 2 solutions, 1 solution, or no solution at all. Okay, cool. So today we are going to be talking about how to solve quadratic equations by factoring. Okay, but before we talk about that technique, first I want to talk to you about the zero factor property, which is going to be key here in terms of why we do what we do. Let's go ahead and put some spicy problems. So let me call them bonus problems. So made up abbreviation. So let's just say I'm like, okay, quick. 0 times your favorite number. What is it? 37? Okay, mine's 2. So I'm like, okay, what's the product? Okay, okay, we know the answer is 0. Another spicy problem. Negative 21 times 0. Oh, answer 0. Oh, you're a genius. Okay, another spicy problem. Okay, 0 times 0. Okay, cool. Now, are these problems going to be on the test? Of course not, because you're too hardcore for that. But whenever possible, I like to touch base on problems that I think you feel comfortable with in order to extend it to what we're going to do right now. Hopefully I made sense. Okay, now what's going on? We have multiplication problems for all 3. Okay, what's going on? For all 3 problems, the product is 0. Okay, so what I want to point out is this: when the product is 0, okay, there's no way around it. When the product is 0, one of those factors has to equal 0. Either the first factor equals 0 or the second factor equals 0. Okay, so again, if you have a multiplication problem and the answer is 0, there's no way around it. One of those factors has to equal 0. Okay, either the first, the second. What about both? Okay, yeah, both factors could be 0, but what we're gonna do today, we're going to exclude the case where both factors are 0. Okay, so let's go ahead and talk about the zero factor property. I don't want you to think like it's something that you have to memorize, like formula. No, it's something that you need to have. It's just something that you need to have in the back of your mind. So the zero factor property states if, big if you have a multiplication problem and that product equals 0. What? We're multiplying 2 things and the product equals 0? Kind of looks like our bonus problems. Okay? If Product equals 0. What did we say before? If a product equals 0, what has to happen? If the product equals 0, then one of those factors has to equal 0. Either the first factor equals 0, so either the first factor equals 0, or the second factor equals 0. Cool. And again, we are going to ignore the third case scenarios, because if both factors equal 0, then we're not going to have a variable in there. Okay, so let's do this. So we're going to do a total of 4 fun problems, and then we're out. Okay, so fun problem number 1. The directions read solve each equation by factoring. Okay, so let's pay attention to the directions. The directions do not give us the green light to solve this however we like. We have to solve it by factoring. Okay, so how do we solve an equation by factoring? So first things first, we want to write the equation in standard form. So it says set equation equal to 0 with first term being positive. So step number 1, write it in standard form. Okay, semi-English, set it equal to 0. Let's go ahead and make sure each side is simplified. That will help us to determine what are we moving. Okay, so the left side, there is nothing to simplify. On the right side, we got this. When we distribute the -4 times the first term will give us -4x. -4 times the second term will give us -8. Fantastic. So step number 1, write it in standard form. In English, set it equal to 0. I don't really care where the 0 stands. Okay, just make sure one side equals 0. For me, I'm going to focus on the biggest exponent, which is 2. The term is the leading coefficient is positive, so I want it to stay positive. So for that reason, we're going to shift those terms to the left. Okay, so to move the 4x, let's go ahead and add it to both sides. And while we're at it, since we have a nice space to line up the constant term, let's go ahead and move the -8 while we're at it. Okay, sorry, my Spanish gets in there. So to undo the subtraction by 8, let's go ahead and add it to both sides. And when we do, that will leave us with 5x squared plus x equals 0. Okay, so step 1 complete. To solve a quadratic equation by factoring, step 1, set the equation equal to 0. Step 2, since we're solving by factoring, then you guessed it, step 2 is to factor completely. Okay, prerequisite step when it comes to factoring is to watch out for common factors, and in this case 5x squared and x, they have a common factor of x. So let's go ahead and do this. So we are going to show the reader what we're left with when we factor out that x. First term over common factor, that will leave us with 5x. Second term over common factor, that will leave us with 1. Okay, fantastic. Okay, so again, prerequisite step when it comes to factoring is to watch out for common factors. So let's look at our resulting binomial factor. The degree is 1, so we can't break it down. For this problem, we got lucky in the sense of just by taking out the GCF, we're done factoring. Okay, so step 1, or how do we solve by factoring? Step 1, set the equation equal to 0. Step 2, factor completely. Step 3, apply the 0 factor property. Okay, so again, 0 factor property states that if a product equals 0, then there's no way around it. One of those factors has to equal 0. So what's going on? We have a multiplication problem that, you guessed it, equals 0. So at this point, we apply the 0 factor property. If a product equals 0, again, there's no way around it. One of these factors has to equal 0. Either the first factor equals 0 or the second factor equals 0. Let's go ahead and write that. So either the first factor equals 0 or the second factor equals 0. Okay, cool. So at this point, now that we have our compound equation, let's go ahead and solve each equation and then take the union. First equation, there's nothing to solve for, so that's it. Okay, so I guess one of the solutions is 0. Second equation, to isolate the variable term, let's go ahead, subtract 1 from both sides, and that will leave us with 5x equals -1. To finish it off, to get rid of the times 5, let's go ahead, divide both sides by 5, and that will leave us with x equals -1/5. Okay, so now I don't want to say popular mistake because it's not a mistake, but you will get dinged for it. Students like to box their answers individually, but remember, or means union. Okay, so I need you to take that union. So in English, combine your answers. So we are solving for x, so we have x equals, and then one answer is 0, and then the other answer is -1/5. Okay. Fantastic. Okay, so that's it. To check it, how do we check it? You check it the same way we would. Okay, you would plug in each number and make sure you get a true statement, but we had no time for that. All right, cool. So again, we had said we're gonna do 4 problems. That is our first one. Let's go ahead and do it, the next one. Okay, problem B. Problem B, we have, where am I? -6 is equal to -48 m squared plus 28m. Okay, -6 equals -48 m squared plus 28m. Okay, so I'm gonna ask myself, first things first, what kind of equation is this? Depending on the type of equation that we have, that will determine the strategy that we will use to solve it. We have a degree 2 equation or quadratic equation, so how are we going to solve it? By factoring. Why? Because that's how we do it, and 2, the direction says solve it by factoring or else. So first things first, we want to set the equation equal to 0 with the leading coefficient being positive. We have a degree 2 term here. The coefficient is negative. It will be nice if it's positive, so let's shift all the terms to the left. Do you have to do that? No, you can just move the -6 and then you'll have it in standard form in a heartbeat. Okay, but let's go ahead, shift these terms. So we're going to add 48m squared to both sides. The 28m will have to be moved in the second trip because I don't want to confuse myself. There's not a space to line it up under. So that will leave us with 48m squared minus 6 is equal to 28m. This is not quite set equal to 0, so no factor property just yet. Okay, love yourself. Let's go ahead, subtract 28m from both sides. And when you do, that will leave us with 48m squared minus 28m minus 6 is equal to 0. Okay, so I'm happy. So again, to solve a quadratic equation by factoring, the first thing you need to do is set the equation equal to 0. So step 1 complete. The second thing you need to do is factor completely. So when it comes to factoring, prerequisite steps is to watch out for common factors. The GCF for all these 3 terms, I think it's 2. Okay, so let's go ahead, factor out of 2, and if there was a larger factor, I guess we'll take it out thereafter. Okay, when we factor out of 2, that will leave us with 24m squared minus, 14m minus 3. Okay, close the grouping symbol equals 0. Okay, so we have factored, but the question is, can we factor more? I'm going to assume that we can until we realize that we cannot. The degree is 2. Together we will factor by using the AC method, but you can factor however you like. You know, box method, happy face method, sad face method, rainbow method, asterisk method, snowflake method, whatever method. It's all AC method in disguise. Okay, so let's go ahead and do this. So when we use the AC method to help split the middle term, we're going to go ahead to do the corresponding X game. So again, go ahead, look at a video from the earlier part of this playlist. So corresponding XK, we want factors of A, C that add up to B. So let me label this for my peace of mind, not necessarily for credit. Product of A and C, namely 24 and -3, will give you -72. Value of B is -14. Okay, so we want factors of -72 that add up to -14. For the purpose for the length of this video, I'm going to give you those side numbers, but you can reference an earlier video that shows what do I do when the numbers don't come. You can reference an earlier video that will show you what I do when the numbers don't come to me. Okay, so that was my last disclaimer. Okay, so let's go ahead, split that middle term using the sides of the X game as the coefficients of the middle term when split. The variable part of the middle term reads m. So when we replace it, when we split the middle term, we will replace it with 4m and -8m. So let's do this. So we have 24m squared. Let's split the middle term. So we'll replace it with positive 4m because 4 is positive, and negative 18m. We bring down the rest of the problem. Okay, I don't want to forget to bring down that GCF, so let's go ahead and bring it down at every part. And while we're at it, we'll bring down our equation. So remember, the gist of the AC method is to split the middle term so you can have 4 terms and then factor by grouping. Let's group the first 2 and we'll group the last 2. From the first team, the greatest common factor, if my eyes don't fail me, I believe it's 4 with an M, or 4m, how normal people speak. When we factor it from the first group, first term over common factor will give you 6m. Second term over common factor will leave you with 1. Okay, so one group down, one more to go. Second group, I need a special effect to cover this up. Let me see if it does the job. Whatever. Okay, we'll let it stick. Okay, that took me longer, so remind me not to do that. So second group, the GCF is 3. Okay, but we want to ensure that the first term is positive. Why? That's the only way that things are going to match up if they're supposed to match up. So we'll factor out a negative 3. Okay, when we factor out a negative 3, let's do this. First term over common factor will leave you with 6m. Second term over common factor will leave you with 1. Okay, fantastic. And we'll bring down the rest of the problem. So we got this. So let me bring down the GCF. Remind me not to use my special effect. Okay, so let's go ahead, finish factoring that trinomial. Now that we took the GCF from each group, let's go ahead, factor the common binomial factor of 6m plus 1. So let's do this. So when we factor out the common binomial of 6m plus 1, first product over common factor, the binomials cancel out, and that will leave you with 4m. Second product over GCF, the binomials cancel out, and that will leave you with minus 3. And let's not forget to bring down the rest of the problem. So all of this was being multiplied by 2. So we have product of 3 factors. Okay, the product equals 0. When the product equals 0, there's no way around it. One of these factors has to equal 0. Either the first factor equals 0, that looks weird, but it is what it is. So either the first factor equals 0, or the second factor equals 0, or the third factor equals 0. Cool. Alright, so let's do this. So if the first factor equals 0, let's go ahead, solve for m. There's no m, and check it out. 2 doesn't equal 0. It's a lie. So we're going to go ahead and ignore it. So this is how it's going to go down. So for future problems, if you just have an integer factor, you have some options. You can either write it and ignore it later, or we can just be like, 2 doesn't equal 0, and we ignore it now, and we go straight to the next factor. It's really a personal choice. This was the first problem, so I wanted to write it in. Okay. So either in this case, the second or third factor equals 0. I'm running out of space. I'm going to do some parts mentally. As you're solving equations, skipping one step at a time in school, when you skip more than one step, that makes me nervous. When we subtract 1 from both sides, that will leave you with 6m equals negative 1. And after you divide both sides by 6, that will leave you with m equals negative 1/6. Okay, so the degree is 2. Where am I? Okay, the degree is 2. So we're expected to have 2 solutions. Okay, we have our first one. Let's go ahead, find the second one. Okay, to isolate that variable term, let's go ahead, add 3 to both sides, and when we do, that will leave you with 4m equals 3. And after we divide both sides by 4, that will leave you with m equals 3/4. Hopefully I did this right, because when I do things in my head, that's when I always make mistakes. Bear in mind that or means union, so I need you to give me a combined statement. If not, then we don't have our answer using the correct notation. We are solving for m, so m equals, one solution is negative 1/6, another solution is 3/4. You can also write your answers in decimal form, but make sure that you never round. Okay, so we were gonna do 2 problems today. Sorry, we're gonna do 4 problems today. That was we knocked out 2. Let's go ahead, do the final 2, and then we're out. Okay, problem C. Okay, Where are we? Okay, let me write the letter C and then I'll zoom out. Okay. Problem C. So we have x minus 11 halves x squared is equal to 3x cubed. Okay. X minus 11 halves x squared is equal to 3x cubed. Okay. Now, is this a spicier problem? Of course it is, because it's problem C. Okay. Now, am I having a moment? Yes, I am. Why am I? I'm having a moment because the degree is not 2. The degree is 3. So this is not a quadratic equation. If you want to show off, you can just tell your friends, hey friends, today we solved cubic equation. So degree 2 is quadratic equation is the special name given to an equation of degree 2. A cubic equation is the special name given to an equation of degree 3. But you don't have to worry about the words, okay? So the question is, how are we going to solve this? Okay, so we're going to solve by factoring because the direction said so. But pretty much if the degree is 2 or higher, we're going to solve by factoring. So first things first, let's go ahead and set this equal to 0. But I'm not going to lie, this denominator of 2 is really messing with my flow. So with your permission, we're going to go ahead and get rid of it. How? We're going to multiply both sides by the least common denominator. There's only one denominator, so guess what? That one denominator is the winner. So let's go ahead and wipe out the fractions by multiplying both sides by the common denominator we just identified. Let's show the reader what we're left with. 2 times the first term that we see will leave us with 2x. 2 times the next term will leave us with 2 times negative 11 halves x squared. The 2's cancel out, and that will leave you with negative 11x. That will leave you with negative 11x squared. So minus 11x squared equals, okay, on the right side, product of 2 and 3x cubed will leave us with 6x cubed. Fantastic. Alright, so now at this point, yes, it's not a quadratic equation, it's not a degree 2 equation, but either way, degree 2 or higher, we will solve by factoring. So step number 1, set this equation equal to 0. Because the leading coefficient is positive, I'm going to shift all the terms to the right. Okay, so let's go ahead add 11x squared to both sides. And while we're at it, we'll move the 2x. Okay, so most of the time, I only move the terms one at a time. If there's a space to line it up under or a free column, then I'll be like a little adventurous and move the terms, move more than one term. Okay, so that will leave us with 0 is equal to 6x cubed plus 11x squared minus 2x. Okay, fantastic. So now that we set the equation equal to 0, now we can factor however we like. Prerequisite step is to watch out for common factors. In this case, the trinomial, the GCF is just x. Okay, so let's go ahead and show off our skills and let the reader know what we're left with when we factor out the GCF. First term over common factor, that will leave us with 6x squared. Second term over common factor, that will leave you with 11x. Third term over common factor, that will leave you with negative 2. So we have factored, okay, but the question is, can we factor more? So I'm going to assume that we can until we realize that we cannot. Because trinomial, because the leading coefficient is not 1, and we're going to go ahead and use the AC method to factor. So AC method, let's go ahead and do the corresponding x game. We want factors of AC that add up to B. So we want factors of A times C, namely 6 and negative 2. Product gives us negative 12. And value of B is 11. So we want factors of negative 12 that add up to 11. So we think about it, do a factor table if needed. And looks like the sides are going to be 12 and negative 1. So let me check it because sometimes my arithmetic is wrong. Product is negative, sum is 11. Okay, we checked it, so we have the green light to proceed. And let's go ahead and split that middle term. The variable part of the middle term reads x. So when we split the middle term, we will replace it with 12x and negative 1x. So let's do this. So we have 6x squared. Let's use the AC method. So we split the middle term and we're going to replace it with positive 12x and then negative 1x. I'm just going to put minus x with your permission, but if you want to put a 1, go for it. We'll bring down the rest of the problem. Bear in mind that the trinomial, well, now 4-term polynomial, is being multiplied by x, and that is set equal to 0. Okay, so AC method, split the middle term and then factor by grouping. When we factor by grouping, we're going to group the first 2 terms and then the last 2 terms. For the first group, the GCF is 6x. And let's show the reader what we're left with when we factor it out. First term over common factor, that will leave you with x. Second term over common factor, that will leave you with 2. So one group down, one more to go. Second group, I'm like, okay, what's the GCF? And I'm like, this is a weird one. Why? Because x and 2 don't have any factors in common other than 1. Hey, if they don't have anything in common aside from 1, then the GCF is just 1. Okay, so we're going to go ahead, put down the 1, and then you know the speech. We want to ensure that the first term we're left with is positive, so we're going to factor out a -1. First term over common factor, negative x over -1 will leave us with x. -2 over -1 will leave us with 2. So as expected, the binomial factors match, so we're good to go. Let's bring down the rest of the problem. So this is being multiplied by x, and that is set equal to 0. Okay, so continuing the factoring process, let's go ahead factor out the binomial factor. Okay, so the GCF is now the binomial of x plus 2. Go ahead, show off your skills. First product over common factor, the binomials cancel out, and that will leave you with 6x. Second product over common factor, the binomials cancel out, and that will leave you with -1. Okay, let's bring down the rest of the problem. Times x equals 0. Okay, fantastic. So now that we factored, okay, to me, when we're solving an equation by factoring, factoring is the toughest part. Like once I factor, sometimes I start to cry because it took me forever to factor. But now I'm gonna take a deep breath and then knock it out. Okay, so product equals 0. Now at this point we apply the 0 factor property. Product equals 0. When a product equals 0, there's no way around it. One of those factors has to equal 0. Either the first, second, or third factor equals 0. So let's do this. Either the first factor equals 0, or the second factor equals 0, or the third factor equals 0. Okay, so we have 3 equations. Let's go ahead and solve each one and then take the union. The first equation, it's already solved for. The second one, oh, I have so much space, so you know the drill. I'm not going to do any mental math, okay? I know how to add, I think, but sometimes when I don't write it out, I tend to make mistakes, so I write things out to protect myself, okay? Second equation, third equation, my mistake. To isolate that variable term, let's go ahead and add 1 to both sides, and that will leave us with 6x is equal to 1. To finish it off, to get rid of the times 6, let's go ahead divide both sides by 6, and that will leave us with x equals 1/6. Now remember, we are solving a degree 3 equation, fancy name or not, but we are solving a degree 3 equation. If the degree is 3, then we're expected. I say expected because sometimes it doesn't happen. Okay, if the degree is 3, then we're expected to have 3 solutions, and we have 1, 2, 3 solutions. Let's just go ahead, take the union. So we have x equals 0, -2, and 1/6. Yes, I know that the solutions are not listed in order from smallest to largest, and I'm okay with that. Okay, so again, we were gonna do 4 problems. This was our 3rd one. Let's go ahead, knock out our 4th and final problem, and then we're out. Okay, problem D. So let me write the letter and then make sure that this fits in. Oh yeah, it does fit in. Okay, problem D, where am I? We have, oh look at that, another degree 3 equation. Check it out. So we have x cubed minus 16x is equal to 32 minus 2x squared. Okay, x cubed minus 16x is equal to 32 minus 2x squared. Now, is this a quadratic equation? No, it's not a degree 2 equation, okay? It's a degree 3 equation. But either way, degree 2 or higher, we're going to solve by factoring. So let's do this. First step is to set the equation equal to 0. Now, right now, the leading coefficient is 1, positive 1, and I need it to stay positive. So for that reason, we're going to shift these terms to the left. So let's move them one at a time. So we'll move the squared term. So we're going to add 2x squared to both sides. And that will leave us with x cubed plus 2x squared minus 16x is equal to 32. This is not quite set equal to 0 yet, so let's go ahead and do so. When we subtract 32 from both sides, that will leave us with x cubed plus 2x squared minus 16x minus 32 is equal to 0. Okay, cool. To solve an equation by factoring, our first step is to set the equation equal to 0. Done. Okay, our second step is to factor completely. Based on the polynomial that you have left, 2 terms, 3 terms, 4 terms, that will be the factoring strategy that you will use to factor. Because we have a 4-term polynomial, we're going to factor by grouping. So let's go ahead, group the first 2, group the last 2. From the first group, the terms have a common factor of x squared, so let's do this. So we factor out an x squared, and that will leave us with first term over common factor leaves you with x. Second term over common factor, that will leave you with 2. Okay, so one group down, one more group to go. The second group, 16x and 32, I believe the GCF is 16, and if it isn't, then we'll take out another common factor. But let's go ahead, factor out a negative 16. That will ensure that we start on a positive note, and who cares if the rest of the terms are negative. When we factor out a negative 16 from the group, first term over common factor, that will leave you with x. Second term over common factor, that will leave you with 2. Okay, fantastic. So moving forward, when we factor a polynomial by by grouping, we group the first 2, we group the last 2, and then we take out the common binomial factor. So let's do this. We take out the GCF of x plus 2, and then show the reader what we're left with. First product over common factor, the binomials cancel out, and that will leave you with x squared. Second product over common factor, the binomials cancel out, and that will leave you with minus 16. Okay, so we have factored, but the question is, can we factor more? Maybe, maybe not. First factor, okay, the degree is 1, so you know you can't break it down anymore. Second binomial, the degree is not 1, so it's like, can we factor more? I'm going to assume that we can until we realize that we cannot. So binomial minus, we have 2 options. So option 1, difference of squares. Option 2, difference of cubes. But the recommendation is to aim for squares and then cubes. So I want to ask myself, do I have a difference of squares? Okay, and because I never see things, I'm going to do the mold. Do I have something squared minus something squared? Hence, difference of squares. Okay, so x squared is a perfect square because it's the square of x. Okay, 16 is a perfect square because it's the square of 4. So to answer my question, do I have, because I'm not going to leave myself hanging. To answer the question, do I have a difference of squares? I sure do. So in this case, the binomial will factor to x plus 4 times its conjugate. So again, we took our time in terms of how to factor difference of squares, so you can reference that other video in the playlist. Alright, let's go ahead and bring down the rest of the problem. So this was being multiplied by x plus 2, and then it's set equal to 0. How do we solve an equation by factoring? First things first, set the equation equal to 0. 2, factor completely, and then 3, apply the 0 factor property. So the 0 factor property states this: if a product equals 0, then there's no way around it. One of these factors has to equal 0. Either the first factor equals 0, or the second factor equals 0, or the third factor equals 0. And I love this problem. After we show the answer, I'm going to tell you why. If the first factor equals 0, once we subtract 2 from both sides, that will leave us that x equals negative 2. If the second factor equals 0, once we subtract 4 from both sides, that will leave us with negative 4. Okay. If the third factor equals 0, once we add 4 to both sides, oh, look at me trying to do this in my head. I'm not trying to impress anybody, sorry. If the third factor equals 0, once we add 4 to both sides, that will leave us with 4. One of the questions that I get is this: oh, Ms. Torres, we applied the zero factor property. You had said that if a product equals 0, one of those factors equals 0. One of the questions that I get is, I think I made a mistake because none of my answers is 0. We didn't make a mistake because we're cool like that. But let me expand. So when I say that the zero factor property states that if a product equals 0, then there's no way around it. One of those factors has to equal 0. Okay? One of the factors, not one of the solutions, has to equal 0. So let me break it down. When x equals -2, well, yeah, I'm going to plug it into this expression right here. Okay? If x equals -2, -2 plus 2 is 0. So the answer is not 0, but this factor evaluates to 0. Okay, if x equals -4, we plug it in anywhere, but I'm gonna pay special attention to the middle factor. Let me put this finger away because it's in my way. Okay, when x equals -4, -4 plus 4 is 0. So the factor is 0, not necessarily the solution is 0. When x equals +4, pretend I substituted a 4 everywhere, but I want to pay special attention to the third factor. When x equals 4, 4 minus 4 is 0, so the factor is 0. So this is what I want to point out. The popular mistake is that students do the math correct, they write their answer, and then for some weird reason, they put a 0 in the answer just for fake extra credit. Don't. Trust yourself, okay? So yeah, so the answer doesn't have to be 0. If it is, cool, but don't force the 0. Okay, so let's go ahead, write our answer by using a combined statement. Why? Because remember, or means union. We need to have correct notation. So the solutions are -2, -4, and +4, and we're out. Okay, thanks guys. Until next time.